All right, guys, let's take a look at our last section. This is last section. I can't even speak. Last section of the year and last section of this unit on set theory. So we're going to be taking a look at section 2-3, set operations. So let's get at it. Okay. So when we look at set operations, we are looking at union of sets, we're looking at difference of sets, we're looking at intersection of sets. So what we're going to do here is we're going to take a look at a class that I had in the past. And in this particular class, what we have is some who are political science majors and some who are athletes. And we kind of separated them out based on that criteria. And you can see that here is the set. This circle represents the set of all the people in that class who are political science majors. So John, Katie, Grace, and Dylan were all of my poli-sci majors. Then we had our set of athletes, this entire set. And so that included Grace and Dylan and Caleb and Rachel and Megan and Tim and Allie. So you can see that Grace and Dylan were both poli-sci majors and athletes, but Caleb, Rachel, Megan, Tim, and Allie were not poli-sci majors, they were just athletes. And John and Katie were not athletes, they were just poli-sci majors. And Noah down here, he wasn't a poli-sci major nor an athlete, didn't fit into either one of those categories. He was his own man. So anyways, we're going to look at all these different ways that we can combine these sets. And the first thing we're going to look at is the idea of a union of sets. And the union of sets A and B is the set of elements that are members of either set. So in other words, it could be a member of set A or set B, or in both for that matter. Here's our key word. That's our operative, the word or. So let's take just a generic idea here. Let's not look at the set that I had before, but let's just say I've got set A and I've got set B. And I want to look at the union of the two sets. Now, by that definition that we just had, it's either a member of set A. Now, everything that's a member of set A is going to be everything through here. Or it's a member of set B. Now, set B is everything through here. Or it's a member of both. So the idea here is that to be a member of the union of set A and set B, it's going to be basically everything that's shaded. Everything shaded because of this word or. Set A, that's all this. Set B, that's all this. Or both of them is right in here. Basically, it's the idea that it's everything that's in either set or A or set B. Now, whenever you've got a union, the notation that we use is a big U. U for union. So this means the union of set A and set B. If we're going to write it in set builder notation, because you know that there's two ways to write sets. One is to just simply list the elements. The other is to use set builder notation. So set builder notation for A union B would look like this. Now, we always use braces to denote set. So we would say X such that. So in other words, the member of this set is going to be such that this element is a member of A, here's the key, or it is a member of B. And there is our set builder notation to denote that. Now, one thing to be of concern is that if you are listing the elements, then these will get listed twice because they'll get listed as an element of A. Then these will get listed again as an element of B, and I don't want to list them twice. So we're not going to do that. You only list them once. So let's take a look at that class example that I had before. Here I've redrawn my sets. Here again, the poli-sci majors were John and Katie. They were not the athletes. Caleb, Rachel, Megan, Tim, and Allie were athletes but not poli-sci majors. Grace and Dylan were a combination of both, and Noah was his standalone man. So if I want to say, for instance, take a look at P union A. In other words, poli-sci union with athletes. This is going to be the set of elements in set P or set A. So remember, set P or set A. Well, everybody in set P, everybody who's a poli-sci major is all of these people through here, because this big circle represents all the poli-sci majors. Everybody in set A, all the athletes, is everybody through here. And the union is everything shaded. So then, therefore, my picture that would represent that would be everything shaded all through here. This is my union of the two sets. Everything shaded. But in terms of listing the elements that are in that answer, my list of elements for P union A would be John and Katie, and Grace and Dylan are also members of the poli-sci group. But now let's move over to the athletes. I don't want to list Grace and Dylan again, so now I'm just going to move on to Caleb, Rachel, Megan, Tim, and Allie. And so this is going to be my set of P union A. So now that's what happens when you do a union of two sets. So let's take a look now at intersection of two sets. And the intersection of sets, by definition, is going to be the set of elements common to both A and B. And here again is our key word. That's the operative word, and. So what happens when I take a look at the intersection of the two? Here's set A, here's set B. And so if I'm looking at set A, that's everything through here. And when I look at set B, that's everything through here. And when I want to look at the ones that are common to both A and B, that's everything right in this section, right in here. So in other words, that's going to be the overlap. And means overlap. And so that symbol for intersection, instead of that U for union, it's going to be flipped upside down. That means intersection. And again, in set builder notation, it simply means A intersect B is going to be, that set is going to be the set of all elements such that that element is a member of set A, and there's my key word. It is a member of set B. Now, here's something interesting that happens. Let's say that when we're talking about that intersection of set A and B, we get an empty set. In other words, there is no overlap. When there is no overlap, it looks like this. Here's set A, here's set B. There is no overlap at all, and we call that a disjoint set. A and B are disjoint if there is no overlap at all. So let's take a look at that class example again. Here was the picture that we had before where John and Katie were the poli-scis that were not athletes. Caleb, Rachel, Megan, Tim, and Allie were the athletes that were not poli-sci. Grace and Dylan were both, and Noah was a standalone man. And let's look at this idea of P intersect A. The poli-sci intersecting with the athletes. This is going to be the set of elements in set P and, there's the key, set A. So here's set P, here's set A, and once again what we want is this overlap area right in here, the overlap. So in terms of a picture, what would my picture look like for P intersect A? This is what it looks like. If I'm going to list those elements that are in that intersect set, P intersect A, then what I will list in there is Grace and Dylan. And those are the two students that are in P intersect A. So hopefully so far what you're seeing is the difference between intersection and union. Intersection means and means overlap, whereas union means or, one or the other or both, and that would mean everything that's shaded. Now let's take a look at a different idea, the idea of a complement. Now complements are the elements needed to complete the set, to get the whole universal set. So if I've got A here and B here, and this is my universal set, the entire box is a universal set. And let's say I want to talk about if A is a subset of that universal set U, and so I'm talking about A right here. The complement of A is going to be all the elements in U that are not in A. That's my keyword, not. So if I'm looking at my picture, here's set A. But if I want everything that's not A, well, that's all of this. However, I want it to be able to fill that whole universal set. So that's everything out here as well. So this is going to be the complement of A. Pretty much everything that is not A, all the way extended out to that universal set. So this is what the complement of A would look like. In symbols, if you see this with that little tilde right there, or that little prime symbol, then that indicates we read it as not A. And whenever you see this symbol, not A, that indicates everything that's in the universal set that is not A, everything else. So in set builder notation, it will look like this. A prime, or in other words, not A, that set is, we use braces to denote set, X such that X is a member, we're used to that notation, a member of the universal set, but X is not a member of A. That's what our set builder notation will look like. So let's play with it a little bit. Let's take a look at our class example again. Same thing we had before. Let's consider those poli-sci majors. But now what I want is P prime. In other words, the ones that are not poli-sci majors. But remember, in order to be a part of that set, then I'm not going to use lowercase p because lowercase p would be the poli-sci majors. I'm going to instead use an O. And I'm going to say O such that O is a member of this class, because that's the universal set. The entire class is a universal set. But O is not a poli-sci major. All right, so in terms of pictures, I want everything that's a member of the class, but not this part right here. So that's everything out here. But don't forget, it has to also be a part of this universal set. So that's everything out here as well, because it's very important that we include Mr. Standalone Noah right there. He's got to be a part of this the not athlete, or sorry, the not poli-sci majors. So this is what my picture will look like. And in terms of listing, remember the stuff that's shaded is a part of my list. So P prime then is going to be Caleb, Rachel, Megan, Tim, Allie, and Noah. Those are all the students right through here that are a member of this universal set, but they are not poli-sci majors. So they fit the P prime bill. Okay, So let's consider those athletes. Well, now I want A prime. In other words, not an athlete, not A. So these are going to be the elements such that the element is a member of the class, because again, that's the universal set. Remember the class. But that element is not an athlete. All right, so that's the set we're looking for. So again, what this indicates is, here's my athletes. I want everybody that's not an athlete, which is going to be out here. But remember, the ones that include that universal set, because that's what not A means. The complement of A indicates everybody that is included in the entire universal set, just not those athletes. So here again, this is what this picture will look like. And so if I'm going to list my A prime set, it's going to be everything that's shaded, none of these athletes. So it's going to be John and Katie. And Mr. Noah down here, that's my standalone. So there is A prime, the set of non-athletes, but included in that universal set. So now, and again, that's what a complement is. Complete the set, complete that entire universal set, leaving out the ones that are not a part of the set that you're talking about. So now let's take a look at this idea of set difference. Difference in math indicates subtraction. And so that's kind of what's happening here. You're going to begin with one set and you're going to remove, that's the idea of subtraction, all the elements that appear in a second set. So let's say, for instance, that here I've got my A and my B, and here's my universal set. So if I see the symbols B minus A, then what that indicates to me is I'm going to take set B and I'm going to remove all the elements that were in A. That's exactly what this says. Start with one set, start with B, remove all the elements that appear in the second set, remove everything that's in set A. So the difference of sets B and A is the set of elements that are in B, because I'm going to start with B, and I'm going to remove everything that's in A. So not in A. So in pictures, let's see what happens here. I'm going to start with set B right through here, and here's all of set B, but I'm going to remove everything that was in A. So I'm going to remove all of this through here. And so what's left right in here, this is going to be the difference of set B minus set A. Start with B, remove out everything that was in A. And that's what my picture will look like. Now, in set builder notation, B minus A is going to be the set that looks like this. The set of all elements such that, that's what set builder always looks like. Elements such that X is a member of B and X is not a member of A. That's what your set builder notation will look like. So let's take a look at that class example again. And in this class example, let's take a look at this idea of P minus A. The poli-sci majors minus the athletes. So that set P minus A is going to be the set of elements in P. So all the poli-sci majors, but not in A. In P, but not in A. So here's all of my poli-sci majors right through here, including these. But I'm taking all my poli-sci majors, I'm taking out those athletes. This is all the poli-sci majors, but I'm going to take out these guys because they're athletes. I don't want them included in my P minus A set. So that leaves me with everybody out through here. This is everybody in P, but not in A. Take out the athletes. So in pictures, this is what my set looks like. And now if I list those elements of P minus A, that would be just John and Katie. Those are the students that were poli-sci majors but not athletes. P minus A. So again, difference, it's like the idea of subtraction. Start with this set, take out that set, list what's left. All right, now, what if we have multiple sets together and we have to do union, or we have to do intersection, or we have to do a difference, or we have to do a complement, and we have to do a lot of these together? Well, then what order do we go in? Well, it's kind of like order of operations. Your arithmetic order of operations says that you work what's inside the parentheses first. And that's exactly what you're going to do here with your set notation, with your set of operations. Do what's inside the parentheses first. So let's say we go with our poli-sci majors, our athletes, but we're going to throw in residents. So the set R is going to be all the elements if that element is a resident. So if any of these guys are residents, they're going to go in this bubble down here. So U is still going to be my universal set is still going to be everybody who's a member of the class. The set P is still going to be all the elements if that student is a poli-sci major. A is still going to be all the elements such that the element is an athlete. And now we're throwing in the R such that R is a resident of the class. So John and Katie were both poli-sci majors, but we're going to say now that Katie is a resident. So she's a poli-sci major and a resident, but John does not live on campus. Over here, my athletes, they were all Rachel, Megan, Allie, Tim, Caleb, and Grace. But now what we're going to do is we're going to say, well, Rachel, Megan, and Allie, they're still athletes, but they are not residents. However, Tim and Caleb are athletes, but they are also residents. Grace here, she's a poli-sci major and an athlete and a resident. And notice I don't have anybody down here who is just a resident, but none of these. Now Noah, he doesn't live on campus, he's not an athlete, and he's not a poli-sci major. He doesn't even fit in here. He's out here because he's none of those. So now let's take a look here at this idea of these order of operations. So if I'm going to do P intersect resident minus athlete. So poli-sci intersect with resident minus athlete. According to order of operations, I do what's in the parentheses first. So according to order of operations, I'm going to do resident minus athlete first. Well, here's all those residents. But this says take out the athletes. So now I'm going to take out this part, leaving me with this down here. But now what's going to happen is I'm going to take that and I'm going to intersect it with the poli-sci majors. So I'm going to take this and I'm going to intersect it with the poli-sci majors. And so those poli-sci majors are going to come through like this. This is all the poli-sci. And I'm going to take what I had shaded down here and intersect it with all this. That's everything right in here. So this is where my answer lies, right in this section right there. So this is my answer, in pictures anyways. But now I need to figure out who's in that bubble. Who's in that part right down there? If I go back and look, oh, that was Katie. So in terms of listing, my poli-sci intersect with residents minus athletes, that's going to be the set that contains just Katie. She's the only one that fits that bill. All right, so let's take a look at a couple more examples of this with these order of operations using multiple sets. And again, the catch is do what's inside the parentheses first. So what I have here, once again, is here's my poli-sci, my athlete, and my residents. This says, first, I'm going to unionize the poli-sci with the residents. So here's all those poli-scis. Unionized with the residents means all of this, everything through here. But now what I'm going to do is I'm going to take out those athletes. So I'm going to take what I unionized, take out these athletes. So I'm going to take this part out because all of these are athletes. Hopefully you guys are seeing it really helps to use pencil. Honestly, I started to do this with different colored pens. And then I realized, oh man, to be able to erase is going to be very helpful with that difference. So I would highly suggest that when you do this, you just grab yourself a real good pencil with a real good eraser. That's the most important thing, is to have that eraser. So here is the picture of what my union of P and R, take out the athletes, this is what my answer is going to look like. So this is what the picture is. Get that good and shaded for you. Alright, so there's my answer in pictures. And now what I'm going to do is I'm going to list my answers. Well, go back and look at the picture. It was all this out here. And if you look at that picture all out here, that was just John and Katie. That's all. So if I'm going to list the elements for P union R minus A, that is just John, keep doing that, John and Katie. They are the two that fit that bill. All right, so now let's take a look at this one. This is P union with R union A. So P union R union A is, let's see, here again is P and A and R. And according to this, I need to do what's inside the parentheses first, R union A. R union A is all of this. Here's R union A. That's this part. And now I need to unionize that with P. Unionize that with the poli-sci majors. So now when I unionize that with the poli-sci majors, here's all of them. And you can see that that's pretty much everything except for out here in my universal set. So my answer is going to be everything that got shaded, because this is a union. Union means everything shaded. Not looking for overlap. Overlap would be my and. Overlap would be intersection. Union is or. Or means everything. So here is my answer in pictures. But listing what's in my listing what goes in my element, or the elements that are in that answer. Go back here. Everything in there was everybody but Noah. So John and Katie and Grace. John, Katie, Grace. Who else? Tim, Caleb. Tim, Caleb. Rachel, Megan, and Allie. Rachel, Megan, and Allie. And those are everybody that's listed in the set of P union with R union A. All right, let's look at one more. So here again, order of operations says go inside the parentheses first. I've got two sets of parentheses, so I got to go way deep inside and do this part first and then work my way out of there. So in terms of going way deep inside, I'm going to do resident intersect with athlete. Here's my residents, here's the athletes. When I intersect those two, that's overlap. Intersection is just the overlap right through here. Now what I'm going to do is I'm going to take that intersection, I'm going to intersect it with the poli-sci majors. Well, here's all those poli-sci majors. The intersection of this piece and the poli-sci majors is everything right in here, just this part. Right in here. However, once I do all that, it says not all of that. So it would be everything but this. So that's going to be everything out here, as well as everything out here, as well as everything out here. So in other words, I better erase all this because it's not this stuff in the middle right there. However, I got to be careful because that not, remember that not means complement, and complement means everything that could include the universal set. So I got to go way out here. And I have to include everything out here as well. So pretty much, this means everything except for that little notch right there in the middle. Everything out here all the way through to the universal set. So in pictures, what does my answer look like? Well, everything that's shaded out here, short of that little notch in the middle. So there's my answer in pictures. And now I'm going to list the elements that are in there. I'm going to list the elements for P intersect, R intersect A, but the complement of that. And so that's everything out here, just not that person that's listed in there. Everybody but that person. So let's take a look at that. Grace was the one in the middle. So that's everything, everybody but Grace, including Noah. So John and Katie and Tim and Caleb. John, Katie, Tim, Caleb, Rachel, Megan, and Allie. Rachel, Megan, and Allie. But as well, Mr. Standalone Noah down here is included in this one, because we want to go all the way out to that universal set. Okay, so hopefully you can see that when you've got multiple sets in there, just follow order of operations. And order of operations says do what's inside the parentheses first, and then extend your way out from there. Now, let's work backwards. Let's take a look at this type of situation. I've already got it shaded. I need to determine what the operation will look like. Well, notice in this particular case, what I'm noticing here is this is almost all of the P. But it's almost like I took all the P and I took out the A. So it would be P minus A. That would take care of this piece right here. P minus A, take out the A. Yep, that's okay. This part over here kind of looks like A, take out the P, because this would be the P, right? So that part would be A minus P. And it looks like what I did was I put them all together. That's a union concept. So I'm going to take P minus A, and I'm going to take A minus P, and then I'm going to unionize the two together. Another way to look at this one is to say, what if I said that I'm going to unionize the whole thing, P union with A, that would shade everything, but when I take out this overlap right here. So I'm going to shade the whole thing, P union A. I'm going to take out the overlap of P intersect A. That would be another way to look at it. And oftentimes you'll find with these that there are multiple ways to represent in symbols what you have shaded in the picture. So either one of those would be fine. Now what about this one? This one, notice it has a lot of P in there. And that P, this part right here is kind of like the intersection of P and A. This piece in here is the intersection of P and R. So I could say that P intersect with A would be this piece up here. And I could say that P intersect with R would be this piece down here. And I'm going to unionize the two, because remember, union means everything's shaded. I'm not worried about overlap at all. So that would be a great way to express that one. We could also potentially, perhaps we could say, actually that would be the best way to say that one. I'm not really sure of any other ways to do that one. All right, let's take a look at the last one down here. This should look familiar with what we did before, but it looks to me like what this is saying is, let's take P and let's unionize it with A, and let's unionize it with R, because that would shade absolutely everything in here. So P union with A, union with R, but we want to take out this little overlap piece. So we want to take out the overlap of the three. And that would express that one. Now, recall that that pretty much was what we had previously in this example right here. The only difference is that was the universal set because of the not. So we don't necessarily want to do that because we didn't shade the universal set in there. So this would be the better way to express that. All right, last thing that we're going to look at here is the idea of a cardinal number of sets. The cardinal number of your sets, very important that you understand that when it comes to cardinal number, these are where you are going to subtract, well, first off, cardinal number is the number of elements in the set. We've talked about that before. Cardinal number looks like this. And so if I see this, what's going to happen is I want to say how many elements are in this set particularly being A union B. The problem is when I go to figure out the number of elements in that particular set, let's go back and look at that A union B. Here is A union B. And if I want to get the cardinal number, I will add up everything here in A, I'll add up everything here in B, but I will have mentioned these twice. I don't want to mention them twice, I only want to mention them once. So if I simply have individual cardinal numbers like you see here, what's going to happen is I need to subtract out that intersection so that they are not counted twice. So in a formula, what this would indicate is I'm going to take the cardinal number of A, I'm going to take the cardinal number of B, so I'm going to figure out how many elements are in set A, how many elements are in set B, I'm going to add them up, but I want to take out that intersection of A and B because I don't want to count that intersection twice. So let's take a look at that class example that we had where we were looking at our poli-sci majors, our residents, and our athletes. So in that picture, let me draw that picture up here one more time for us so we can reference it. We had, okay, poli-sci was here, athlete was here, resident was down here. Grace was right here in the middle. This is too small to see. John was out here. Katie was right in here. Tim and Caleb were in here. We had Megan, Rachel, and Allie out here. And we had Noah down here in the corner. So if we are going to do the cardinal number for the poli-sci majors, cardinal number for poli-sci, now that's this entire circle right here. I've got 1, 2, 3 elements in poli-sci because I had 3 of them that were in that one. Now, if I'm going to do the cardinal number for the residents, residents are down here. I had 1, 2, 3, 4 of them. If I'm going to do the cardinal number for the athletes, as you see right here, cardinal number for athletes, that's up here. Everybody in that circle is 1, 2, 3, 4, 5, 6 of them. Now if I want to do P union R, poli-sci union with residents. Now one way I could do it is I could say, well, let's take all these poli-sci and let's take all these residents, we'll add them up, but we want to take out the intersection. So I'd say, well, the cardinal number for poli-sci plus the cardinal number for the residents, but we want to take out that intersection of the two because I don't want to count them twice. Cardinal number for poli-sci is 3. Cardinal number of residents for 4. The intersection of the two right in here is going to be these two. Let's take out them. So 3 and 4 is 7. 7 minus 2 will give me 5. So there are 5 elements in the union of P and R. Now you may be looking at this going, why did you go through all that? Because all you had to do was the union is going to be 1, 2, 3, 4, 5. That's easy enough. But I wanted to go through this idea because what if I didn't have a picture? And what if all I had was knowing that the cardinal number for P is 3, cardinal number for R is 4, cardinal number for A is 6, and what if the only other thing that I knew was the intersection of these two was a 2, and I didn't have a picture? Then in order to figure out the union, I would say 3 plus 4 minus the intersection of 2, and I would still be able to do it without a picture. Now let's go with this one. Cardinal number for P minus A. So that indicates all of the poli-sci take out the athletes. So here's all the poli-sci. I'm going to take out this athlete right here, leaving me with only 2 elements. This one is intersection of poli-sci, resident, and athlete. Poli-sci, resident, and athlete intersection is right here in the middle, and that was just Grace. And so we have 1 element in there. Circle all these answers here. This one, I want the cardinal number 4 when I do poli-sci union with A. Here's all the poli-scis union with A. Now poli-sci union with A is going to be 1, 2, 3, 4, 5, 6, 7, 8 of them. But I want to take out resident union with athlete. So resident union with athlete here is going to be 1, 2, 3, 4, 5, 6, 7, 8. But notice what happens here. When I do poli-sci union with athlete, and that's all of these guys right through here, and it helps to shade it, so that's everybody through here. Now I'm going to take out resident union athlete. Resident union athlete is everybody through here, but I want to take all that out. So I'm going to take out here and here, leaving me with just this. Let's see, poli-sci union with athlete is everybody through here. But I'm going to take out resident union with athlete. Resident union with athlete is through here. But I want to take that union out of my original one. So take that out of here was the original. Here was the original. There we go. However, right through here, it takes Grace out as well. Okay, there we go. So we end up with 2 as the cardinal number in there. So hopefully you're seeing that this symbol represents cardinal number. And again, it goes with the idea of difference, goes with the idea of intersection, goes with the idea of union. And if you don't have a picture and you need to get that union, you're going to get the number in each element, but take out that intersection. Now this leads us to what is called De Morgan's law. And De Morgan's law is very helpful in terms of being able to see that overlap idea. What De Morgan's law does is it says, what if I want the complement of A union B? And I want a quick way to get there. The complement of A union B. Well, A union B is, and here's A, and here's B. Here's A, here's B. The complement of A union B is the same thing as the complement of A, the complement of B intersected. So let's compare these two. A union B itself, this part right here, is all of this. But remember, if I want the complement, I want everything except for that, everything that creates that universal set. So that would be everything out here, not including what I shaded in those circles. Everything out here. Like this, but not this in here. There we go. That is the complement of A union B. Now let's take a look at A prime intersect with B prime. Not A would be everything but A, including that universal set. Everything just not A. So that's everything out here. Here's my universal set. Now, not B would be everything in the universal set, but not B. So that's everything out here. I want the intersection of the two. So what got shaded twice? This only got shaded once. It's not a part of it. This only got shaded once. It's not a part of it. Everything that got shaded twice is everything out here in the universal set, but none of those circles. Now, compare these two pictures. They are exactly the same. So that proves that De Morgan's law actually is true, that if you take A union B and you do the complement of that, it's the equivalent of A prime, or complement of A, complement of B, but the intersection of the two. Now another facet of De Morgan's law says I can take A intersect B and do its complement. It will be the same thing as A prime, B prime unionized. So let's compare those pictures. So here is going to be A intersect B, but the complement of that. So A intersect B is right through here. And if I want the complement, then remember that means everything in the universal set, just not what I just talked about. So everything in this universal set, everything out here, just not what I talked about initially, which is right through here. So this is what A intersect B, the complement of that. This is what that looks like. Now, let's take a look at A complement, B complement, the union of that. And we're going to compare those two pictures. And you're probably thinking, I bet they're the same. Yeah, we're going to find out that they're the same. So complement of A is everything in the universal set that is not A. So that's everything out here. Now the complement of B is everything in the universal set that is not B. That's everything out here. I want the union of that. So I want everything that's been shaded, literally everything that I just shaded, which is everything out through here. And you can see that, in fact, yes, they are the same picture. So again, proving De Morgan's law. Now, in terms of remembering De Morgan's law, notice what happens here. I have the union of the two, complement, would indicate basically, let's distribute that complement and flip the symbol. And that will give me A complement, B complement intersected. And that's exactly what happens here. I'm going to distribute the complement, and I'm going to flip the symbol. A prime, B prime, flip the symbol to union. And that's what De Morgan's law does. And it allows us to find our pictures a little bit faster at times and find the elements in the set a little bit faster. So I hope this helps with your set operations. Flip that around there. Okay. I hope it helps with set operations. And remember, the biggest thing is difference would be, what do you think? It's a subtraction. Union for the U means everything that's shaded, because it's the idea of one or the other or both. So it's everything shaded. The intersection, which is the upside down U, is going to be the overlap, because it's the and idea. It has to be this one and this one, so it's the overlap of the two. And then complement is everything except for what you're talking about, so that extends out into the universal set. And then when you have more than one operation and you've got more than one set, then you're just going to follow order of operations. You're going to do what's inside the parentheses first and work your way out from there. So I hope that helps. You guys have a great day.